All right, so the main point of this exercise is to basically figure out the difference in the fact that if you look at A right here, you'll notice that A is continuous, okay? But B, C, and D are all not continuous. So these are all not continuous. Okay, and you can kind of see why based on the standard definition of continuity. I shouldn't say standard, but a very informal definition of continuity. It's if you can draw, between a certain interval, if you can draw a graph without lifting up your pencil. So if you were actually trying to draw this, you'd have to lift up your pencil for this, you'd have to lift up your pencil for that point. So you can tell that this is not continuous. Same with this one. If I was drawing this, I would have to lift up my pencil here and then draw the rest of it, and then same with this one. So B, C, and D, by an informal definition, are not continuous because you have to lift up your pen or pencil when drawing it. But we want a more formal definition of continuity involving limits, because it's not very mathematical to say, well, you can draw it without lifting up your pencil. And that's kind of where limits come into play. So for this exercise, basically for this challenge, that's what I'm trying to ask you to do, is to figure out, using based on B, C, and D, the fact that they're not continuous, and using limits, how can you explain that? If you notice at C, I made it where it's not continuous at C each time too, just to kind of give us a reference point for each of these. So if you do not want it to be spoiled, if you want to actually try to figure it out yourself and try to actually, go through that thinking to figure out why B, C, and D are not continuous based on limits, if you can somehow define continuity based on limits, then don't watch the rest of this video. Otherwise, spoiler alert, I am going to be going over why B, C, and D are not continuous. All right, so the first thing that I'm going to do is, I already kind of pointed this out, that B, C, and D are not continuous at point C right here. Okay, it's not continuous because there's a hole, and then there's this little island here. Here there's a jump. Here it's an asymptote that's happening at C. So basically, we need to figure out, again, like what I said before, is using limits as well as some of our old algebra to kind of explain, to describe what continuity is. And basically, the way that you can explain this is, the reason why this is not continuous is because although f of C exists, so I'm going to write that, f of C does exist, it is some value. However, the limit as x gets closer to C does not, for f of x, for this function f of x, does not equal what f of C is. Okay, f of C exists, it's whatever this y value is right here. So whatever this y value is. However, this limit, as you get closer on this side and get closer on this side, this limit is actually not going to match this point right here. So because of that, because of this reason right here, although f of C exists, this right here, because it's not equal to f of C, that basically defines its continuity, or defines why it's not continuous, I should say. Okay, now let's look at this one. Again, f of C does exist, so I'm going to write that down again. F of C exists. However, the limit as x gets closer to C of f of x does not exist. So I'm going to write DNE. Okay? The limit of f of x as x gets closer to C, this is a C right here, does not exist. Because it does not exist, then this is not continuous. So basically, we do need the limit of f of x as x approaches C to exist. It's also not equal to f of C, so it kind of also matches what we wrote previously here. Okay, same thing here, only this time f of C is undefined. So because f of C is undefined, there's no way that f of C could be equal to the limit of f of x as x gets closer to C on this. Also, the limit as x gets closer to C of f of x does not exist. How can I use these three instances to basically explain continuity? Well, basically, to be continuous, you need f of C to exist. Okay. Also, the limit of f of x as x approaches C has to be equal to f of C. So not only does f of C have to exist, it also has to be equal to the limit of f of x as x is getting closer to C. So if you have any questions about anything in this video, let me know.